Hi, and welcome back. So, over the past couple of videos, we've been talking a little bit electrons and orbitals. And if you remember from a few videos ago, we were taking a look at this picture that we had. And the first time I said that this picture was going to represent a helium atom. And then I think the second time I brought this picture up, I said that it was going to represent a hydrogen atom. And we're going to hopefully see in this video that a hydrogen and a helium atom, if you could look at them close up, they really do look pretty much very similar. They do look very similar. And if we remember, we had our nucleus right there in the center of the atom. And pretty much what I'm going to try to talk about in this video is, if we remember, this was essentially an orbital. And an orbital was really just a probability function of where we might be able to find an electron. So if this was a hydrogen atom, then there would only be one electron in this cloud. If this was a helium atom, there would essentially be, in this cloud, there would be two electrons. And similarly, between both of those, where we have darker shades, of gray and shades of black, you have a higher probability of finding an electron, whether it's a hydrogen atom or a helium atom. And this model, I guess, only works for if we have only two electrons. But as you can probably see, on our periodic table, we've got lots and lots of elements that have got way more than two electrons. So you might start to ask yourself, when looking at a diagram like this, what happens when we, does this shell or this thing, this orbital start to fill up, or do we still have the same distribution? Or you might just ask yourself, well, what happens when we start adding more electrons onto our different atoms? And the answer, I guess the straightforward answer of what happens, is we start adding more orbitals. And again, it's important to realize that these orbitals, they're just probability functions. They're probability functions of where you're most likely to find an electron that, I guess you could say, belongs in a certain orbital. So essentially, we are going to, when we start adding more than two electrons, so we said, that this depiction I've got could be either a hydrogen atom or a helium atom. And when we start adding more electrons on top of just the two electron examples that we've been talking about, we start adding on more orbitals. And one of the things that this will definitely become, I guess, maybe a bit more obvious as we progress through electron configurations. But one of the big rules, and we'll talk about why this is probably not for a while in the playlist, but we will talk about this. Each orbital that we're going to draw, so each orbital can hold, so I'll write this down, each orbital holds two electrons. So you could say, oh, I went off the page there, sorry about that. So each orbital holds two electrons. So you could say that, this orbital that we have could be either a hydrogen atom, and you could say that when we have a hydrogen atom, there's only one electron in here. So you could say in this orbital, there's room for one more electron. So when we have a helium atom that we put into the orbital, that this orbital is full, because each orbital that we're going to be drawing can hold two electrons. So that's, I guess, the first thing. The second thing I want to talk about is how these orbitals can take on different shapes. And it's, well, let me actually just start off. I'm going to show you, this is the same graphic that Sal shows on the Khan Academy videos of orbitals, and it's the graphic off of Wikipedia. So essentially, what this picture is that I drew up here, what this picture is of either a hydrogen atom or a helium atom, where this shows up on the table down here is this right here, and it's drawn very very small on this depiction, but essentially all that is it's a sphere. It's a sphere. I guess you could say there's a higher concentration. There's a higher likelihood of finding an electron towards the center of the sphere than towards the edge of the sphere, and this is going to be called the s orbital. So we have here the s orbital. And essentially what we're going to see, and you also see over here this n number, n equals 1. Essentially what this n number is going to correspond to is the period on the periodic table. So if you remember the periods from the previous video, the periods are just the row. I guess so. They're the rows across. So this is period 1. This is period 2. This is period 3, 4, 5, 6, and 7. So you could say, so this is essentially where n is equal to 1, and this is going to be our only orbital for this first period. We're going to have one s orbital for elements that happen in the first period, and that makes sense, right? Because we have got because we've only got 2 elements in our first period, and 2 electrons can fit into 1 orbital. So therefore, this first period only needs one orbital in order to hold all the electrons that it needs to. And one of the things, actually, you know what? I am going to do this right now in order to talk about. Or else, actually, you know what? I'm getting ahead of myself. Sorry. So pretty much the important thing to realize right now is that this first period, so the electron configuration, what we would pretty much write for the electron configuration is we're going to write our period. So if we were taking a look at hydrogen, what we're going to write for our electron configuration, so I'll write down if we were looking at hydrogen, and we wanted to write out hydrogen's electron configuration, we would start out by writing the period. So we're going to write 1. That's the period that hydrogen is in. We're going to write the type of orbital that an electron is in, or the electron we're concentrating on is in. So the type of orbital that the type of orbital that I've been drawing, and the type of orbital that we've got on our table down here is an s orbital. So we're going to say hydrogen is 1s. That's our type of orbital. And s, by the way, stands for sharp. I maybe in the future in a future video I'll talk about why s stands for sharp. And then the last thing we're going to do, so we've got 1, that's the number of our period that we're in. We have s, which is the kind of orbital that we're looking at. And then the last thing we just have to do is put in the number of electrons in this orbital. So we have 1s1. And that's the electron configuration for hydrogen. Let's do the one for helium. Let's do helium. So we take a look at helium. And helium, it's going to look very similar to hydrogen, because remember, it's the same exact orbital, and we can fit 2 electrons into each orbital. So what we are going to say about helium is helium's electrons fill up. We're in period 1, so we have period 1. Again, we are in the type of orbital that our electrons are filling are the s orbital. And how many electrons do we have in that orbital? Well, we've got 2 of them, right? And therefore, this orbital is full. So, and that's why a little bit, and I'll definitely talk more about this in the future, but that is a little bit of why helium is a non-reactive. Helium doesn't is an unreactive element because it has, you could say, its outermost orbital shell is completely full. It doesn't need any more electrons to have, I guess, you could say, a balanced collection of electrons around the atom. But anyway, I'm kind of getting ahead of myself with that. The important thing to realize is that for these electron configurations, what we're going to write out is, and this will be, I'll explain this better in the next video, but essentially what we're going to write out is we're going to write out the period that we're in, the type of orbital, and we were just looking at the s orbitals in this video, and that's what these, you can, the S stands for sharp, but the s orbital is a spherical orbital. It's this orbital that we've been looking at for the past few videos. So you write the period, the type of orbital you have, and then you are also going to write the number of electrons in that orbital. So anyway, I'm actually out of time for this video. In the next video, we're going to start talking about these other types of orbitals. So probably you can see that these orbitals start to take on some pretty interesting shapes. You know, the s orbital, it's definitely, you know, interesting from the perspective of, you know, it's just a probability function of where we might be able to find an electron. And these other orbitals are probability functions as well, but you can see that there are some pretty, you know, like this is a pretty weird shape that we've got for this orbital. So, you know, and there are lots of strange shapes. So we're going to start trying to tackle some of these shapes and start trying to understand them in the next video. So thanks so much for watching, and I'll see you soon.